So in this video, we're going to learn what composite functions are. So composite functions are when another set of a function is applied to the result of another. For example, if you had an f of, let's say an f of x, which equals to 2x plus 3, and then you had another function, let's say gx equals x squared. Both of these are separate functions that can stand on their own. However, the x in these functions serves only as a sort of placeholder. To not get confused, we will call these x simply as the input, like this. So we're putting the input and we're replacing the x by the input. Oops, sorry. And here we have g of input equals input squared. So you see it like this. So let's say we have our first problem. Using the information that we just went over, how do we solve the following? Let's say, here's the problem number 1. gf of x. How are we going to solve this? Well, so we know that both of these letters equal to, as we mentioned before, the f here, equals to the f of x equals 2x plus 3. So 2x plus 3 is what the f equals to. And then the g is going to equal to the x squared. To solve these types of equations, we take the value of the second letter, or function, and plug it into the input of the first letter, or the function. So we take the f and we plug it into the g. So we always take the second letter and plug it into the g. For example, so you see this. Here is how we start solving. And so the f goes into the g. We should always remember that. And so we can rewrite this to make it a bit clearer as g of f of x is equal to x squared. But remember how in the first part I said that the x is just the placeholder for the other, what you're going to input, the value that you're going to input. So we're going to make this less confusing, we're going to change the x to inputs. So if we're inputting the f into the g, so we know that the value of f of x is 2x plus 3, so our input is 2x plus 3. And so we input this in our equation like this. F of 2x plus 3 is equal to 2x plus 3 squared. This is how we're going to continue and figure it out. Remember that when you solve for this, it's 2x plus 3 times 2x plus 3. And we've got to use the distributive property, of course. So 2x times 2x, 3 times 3, 2x times 3, and 3 times 2x. And so we're going to be left with 2x times 2x is 4x squared, plus 3 times 2x would be 6x, plus 3 times the other 2x would also be 6x, and then you would have plus 9. So you add the like terms, which are 6x and 6x, you get 4x squared plus 12x plus 9. And that would be the answer to your problem. However, what would happen if the letters were reversed? If you had what is the f of g of x, fg of x. So the same rules apply. You just get the second value, which is the g, and you plug it into the f. So we know, as we said before, that f of x equals 2x plus 3 and g of x equals x squared. So if you're trying to plug in the g into the f, you get the x squared and plug it into the input here, which are the x's. So, continuing, you will get something along the lines like this. So you rewrite it as the input, and you will get to input plus 3. And so our input, as I mentioned before, is x squared. So we put that as the input. Which is, so 2x, 2 in parentheses, x squared is just 2x squared plus 3. And that is the basic concept when solving composite functions. However, there is a part B to this question. In this question, you're given the equation that f is 2x minus 3 equals to 8x squared minus kx plus 24. And the problem asks that we have to find the value of k. We can start figuring out the value of k by referring to the last function in the previous problem, which was that f of x equals to 2x squared minus 3x minus 3. If we were to apply to the 2x minus 3 from the second function, input it into the x of the original equation, we would get a function resembling the second one, except that we will be able to figure out the value of k, like this. So we get the 2x minus 3, and we input it into the x squared here, and the x there, as well here, just to show what you have done. And so doing this, we will get the value of k as following. We would get f of 2x minus 3 equals to 2x minus 3 squared minus 3 multiplied by 2x minus 3 and minus 3. This will be our new equation. So we continue solving this, and we get 8x squared minus 24x plus 18 minus 6x plus 9 minus 3. This was by multiplying this outside the brackets like this. 2x minus 3, 2x minus 3. Don't forget to multiply like this, and like that, and like that. And that's how we got this. So we continue, and then this part here was also distributed like that. So we continue solving this, combining the like terms. So we get 8x squared minus 30x plus 24. And so we get this equation that is very similar to what we have done, what we got here from the f 2x minus 3. So we compare what we got here, which was 8x squared minus 30x plus 24, and what the equation with the k was, which was 8x squared minus kx plus 24. And so we look at these like terms. It's basically the same equation, except now we know what the k is, which is 30, because they're the same equation, like that. And so, like this, we figured out what k is equal to. This is another question from an IGCSE past paper, where we were told that the function of f is defined as f of x equals x over x minus 1. So what would happen if f wasn't f of x but was f of 3? And so simply what we have to do is plug in the 3 into the x, replace the two values. So if you plug in the 3 into the x, then this becomes 3, and so does this x. So like this. And so we subtract the 1 from the 3, like this. And we will be given the answer to 3/2. And that's how you would solve this problem. And the final problem, which is basically the same, but with a negative number, is f is minus 3. So we do the same. We plug in the negative 3 into the x here, there, and there, like this. So as this is a negative number, if you subtract a number from another negative number, that would be it would become a greater negative number. So it's minus 4, and this is minus 3. And so if there are two negative numbers, one over another, the minuses cancel out, and you would get 3/4. And that's how you would answer this question. Thank you so much. I hope this helped.